In this example, we are given several number lines and we are asked to state the domain of each line using either a discrete list or set notation. The first line has 4 unconnected points. We can express the domain as the discrete list -5, -1, 4, 9. We don't have to worry about range when dealing with number lines since they are one-dimensional. In this number line, we have a closed point at -3 and the line extends forever rightwards. Let's go through the set notation step by step. First of all, set notation is encased in curly braces. Next, we have to state what variable we are looking at. In this case, we are looking at n, so we write n, then a vertical bar. We read this out as the phrase, the domain is n such that. Now we state the condition applied to the variable. All of our allowed n values are -3 or greater, so we have n is greater than or equal to -3. After the condition, we have to indicate what number set we're using. Whenever you're dealing with a continuous line, you will be using the set of real numbers. Write a comma, then n epsilon r. N is the variable, epsilon is a Greek letter meaning belongs to the set of, and r is the symbol for real numbers. Applying our work to part B, we read this as, the domain is n such that n is greater than or equal to -3, where n belongs to the set of real numbers. The number line in part C has an open endpoint at -1 and extends to the left forever. The condition is n is less than -1. Since it's an open endpoint, do not use the less than or equal symbol, just use the less than symbol. We read this as, the domain is n, such that n is less than -1, where n belongs to the set of real numbers. The number line in part D has open endpoints at 1 and 6. Before tackling this domain, we need to learn something called in-between notation. In-between notation is used whenever you have a domain or range that starts at one value and ends at a different value. It's really easy to use. Just plug your numbers into the template, lower number, less than n, less than higher number. In-between notation always uses a less than sign followed by a second less than sign. However, if a particular point is included in your data set, you can also use the less than equals sign. Returning to part D, we can write the condition as 1 is less than n, which is less than 6, since 1 is the lower number and 6 is the higher number. We read this as, the domain is n, such that n is between 1 and 6, where n belongs to the set of real numbers. The final number line has an open endpoint at -7 and a closed endpoint at 3. Using in-between notation, the lower number is -7 and the higher number is 3, giving -7 less than n less than equals 3. We'll use the less than or equal sign since there is a closed endpoint at 3. So far, we have expressed all of our domains using full set notation. This is the most technically correct way of doing it, but as you can see, a lot of the parts are pretty redundant. The curly braces, the n vertical bar, and the n epsilon r have a presence in every single expression. The most interesting information is the condition, and you will often see set notation condensed to just the condition. So instead of the full expression, the domain is n, such that n is between -7 and 3, where n belongs to the set of real numbers, we can use a condensed expression, the domain is between -7 and 3. This is much less wordy, and it still conveys the most important information. For the rest of this lesson, we will use condensed expressions for domain and range.